Hi guys, today I'm gonna run through a demo on the algorithm of precision learning in dual form. So firstly, let's have a look at the pseudocode. Yeah, I know it looks pretty complex and maybe hard to get a hand of it just looking at the pseudocode. So let's actually do an example. So so here is an example. Say I only have a training dataset of two data points. And they each of them have a label. So how am I going to use this data set to perform the dual perception training? So firstly, let's recap a bit the difference between the primo machine learning and dual learning. So for primo, when we do a perception learning, our goal is to find an omega um, that for every data sign for every data set in for every data point we always have this the sign of transpose omega times xi it's equal to the sign of the label, but in the dual form our goal is different. We don't find such a omega by trial and error. Instead we just compute it by iteration, and the formula is like this. It's the sum up of all the alpha I times yi times xi, and I range from 1 to the absolute value of d, and d here refers to the data, to the number of the data set. Okay, so let's refer back to the pseudocode and try to run it iteration by iteration. Okay, so firstly, we set the converged label to false. And while the converged label is false, we start to train. When we start to train, we first set the converged table to true, such that we assume no modification is required. And then we stop to loop through I equal 1 to absolute value d. Okay, so here back to our example. We So what will be our setting? Our setting will be absolute value d is 2, and we just initialize the alpha because we have only two data sign here, the two data point here. So we're gonna need two alpha. We initialize both of them to be 0, and we start to training the first iteration. Just a bit to record that the condition to check is whether at this iteration whether yi times the sum up whether this condition is hold. We don't know, so we sub in all the value we have here. So first iteration, and I equal 1. So we check whether yi is ranging from 1 to 2 because the absolute value is 2. So we just we just expand the sum like this, and we sub in the value here. So noted that our y1 equals 1. So sub it back to here 1 times, and noted that our alpha1 and alpha2 are all initialized to 0, right? So we just plug in here 0 times something. We don't bother to calculate here. And we know that the answer is 0. And so it's less than or equal to 0. So in this case, the condition is triggered. So what we're going to do is we need to increment our alpha I, and in this iteration is alpha 1. We're going to increment. So now alpha 1 becomes 1, and we set the flag converge to false. It means that we detect something that need to be modified, need to be refined, and we set it to false. Okay, and we loop through I equals 2. Still, we run through the same condition check. And we sub in I equals 2 here. I'll just expand this sum notation. So alpha 1, y1, x. So we plug in the I here, x2 times x1 plus alpha 2, y2, and x2 times x2. So what do we got here? We know that currently our alpha 1 equals 1 and alpha 2 equals 0. So we sub in, and our y2, I think it's minus 2. Okay, so minus 2 here. 1 times 1 times the dot product of x2 and x1, and this bunch reduced to 0 times something, so we don't need to calculate it. So the final result will be, so we check back what is the dot product of x1 and x2. So we calculate this dot product is 2. So minus 2 minus 1 plus 1. So the final answer is 2. It's larger than 0. So when I equals 2, no update required. Okay, so by now we finish one loop, and currently noted that by the end of this iteration, our converged flag is set to false. So we still need to do one more iteration, some more iteration. So what we do, so let's refer to the lecture slides. So so actually we already finished the iteration here, but we need to, because the condition is still hold, we need to enter this while loop again. So we set the flag to true again. And now we loop through I again, start from I equals 1. And we do the condition check again. Plug in the number now. Note that our current alpha and y1 is 1. So it's reduced to x. So it's x1 dot product with x1. So refer back to what is x. Yeah. So that will be 2 squared plus 1 squared plus 1 squared. That's larger than 0. So the condition is not hold here. So no update. So noted that no update. So currently our converge flag is still true. Okay, keep looping the other iteration. So I just sub in I equals 2 here. So our condition will be y2, 1, y1, x2, x1, so y2 is minus 1, and still alpha 1 equals 1, alpha 2 equals 0. So we still need to only calculate this half. So 1 times 1 times x1 dot product x2. So similar to previous iteration, we have it's 2, still larger than 0. So no update again. So our converge flag remains to be true. So the final alpha, it's found here. And now we can calculate our final omega. Final omega 2, 1, 1. So that's the final answer.